You're sitting in your home office late at night, coffee gone cold beside you. The cursor blinks on your screen as you review one last pull request before pushing the latest build for your company's flagship app. Everything looks clean. Tests pass, dependencies updated automatically as usual. You hit merge, trigger the CI/CD pipeline, and lean back, satisfied. Then your phone buzzes with an alert from the monitoring dashboard. Unusual outbound traffic from a handful of customer servers. Strange. You refresh the logs. Nothing obvious. But as you dig deeper, you notice a subtle delay in one of the core libraries your entire stack relies on. A library used by millions. You dismiss it at first, just network jitter. You're about to close the laptop when an internal email lands in your inbox. It looks legitimate, from your own security team. Urgent. Verify your credentials on the new portal. You click the link. The page loads perfectly. You enter your password. That is when the lights in your digital world start to flicker. Welcome to the Subtext Project. Tonight's story follows a lead DevOps engineer at a mid-sized telemedicine provider serving hospitals across the Midwest. The company had built a reputation for reliable, secure virtual care. Their platform connected doctors and patients with end-to-end encryption and strong access controls, or so everyone believed. The engineer took pride in keeping things tight, enforced signed commits, scanned dependencies weekly, and made sure every update went through rigorous review. But like most teams under pressure to ship features fast, they leaned heavily on open-source libraries. One in particular, a popular compression and utility package, had become central to their data pipeline. It handled patient records efficiently and was trusted across the industry. The trouble started months earlier, far from the company's offices. A contributor had joined the open source project on a well-known repository. This person was helpful, polite, submitted clean patches that fixed long-standing bugs. Over time, the original maintainer, overwhelmed and grateful for the support, gave the contributor more access, commit rights, then release responsibilities. It felt like a win for the community. What no one realized was that the contributor was not who they seemed. Behind the screen was a sophisticated actor, patient and methodical, who had spent over a year building trust. In the latest release of the package, buried deep inside what appeared to be benign test data and compressed binary blobs, sat dormant malicious code. It was designed to activate only under specific conditions, after the package had been pulled into production environments at scale. No flashy exploits, just quiet persistence. At the company, the pipeline pulled the updated package automatically. The build succeeded. The signature on the package checked out because the attacker had compromised the maintainer account and the signing process upstream. Days later, during a routine patient data sync, the backdoor woke up. It established a covert command and control channel that blended with normal telemetry traffic. From there, it enumerated the internal network, escalated privileges using a legitimate service account, and began exfiltrating encrypted patient records in small encrypted chunks that looked like routine analytics uploads. The engineer noticed the anomalies too late. By the time the security team isolated the issue, sensitive health data from thousands of patients had already left the network. The attacker did not stop at data theft. They pivoted laterally, planting ransomware that encrypted key databases and demanded payment in untraceable cryptocurrency. The company's operations ground to a halt. Doctors could not access records. Patients waited anxiously. The organization faced regulatory fines, lawsuits, and a shattered reputation. The hack succeeded not because of a brilliant zero-day in the company's own code, but because trust in the supply chain had been weaponized. The compromised library acted like a Trojan horse that thousands of organizations had willingly invited inside their walls. That brings us to the subtext. This scenario is not science fiction. It mirrors real incidents that have already occurred. In 2024, a major open source utility project nearly suffered a devastating backdoor insertion after a long-term social engineering effort by a contributor who gained maintainer trust. The attack was discovered almost by accident just before it could spread widely through major Linux distributions. Similar patterns have appeared in package hijacks and other open source ecosystems where maintainers are overworked and undersupported. Software supply chain attacks surged in recent years, with malicious packages in open source repositories increasing dramatically. Attackers target the weakest links, single maintainers, build pipelines, and the implicit trust we place in widely used dependencies. Even code signing can be bypassed if the upstream process itself is compromised. The takeaway is sobering. In our interconnected digital world, your security is only as strong as the least scrutinized component in your supply chain. Organizations must adopt practices like software bill of materials tracking, regular dependency audits, reproducible builds, and tighter controls on who can push updates to critical projects. For individuals and companies alike, vigilance means questioning not just your own code, but every piece of software you inherit from the community. Stay alert out there. The next update you approve could carry more than new features. If you liked this episode, please consider subscribing to support the channel. Stay curious, stay safe, and question the signals. Until next time, this is the Subtext Project.